Good afternoon and welcome. So, the talk after the lunch is the toughest one because that has the onus to get people out of their slumber. So, I'll try and do a good job at it. Welcome. So, about this talk. This is about Goose. It is a background processing library in Clojure. Now, many of you might be wondering, we built Goose 2 years back. Like, why did we build Goose? So, as part of my onboarding at nilenso, I learned Clojure and I fell in love with it. And at nilenso, they had been using Clojure for around 8 to 10 years. And they had seen that a versatile, powerful, feature-rich background processing library was missing in the Clojure ecosystem. So, I felt like, why not? So, we built Goose for fun. And you might be wondering that, okay, sure, background processing library. You ported an idea from one language or one other library into Clojure. But that's not what Goose or this talk is about. This is about us having like the privilege when designing, building Goose, that we had the second most advantage. So we could see and learn from the gaps of other libraries, and we have redesigned certain things, and that we feel everyone, users of Goose, have found useful, and you all will find it interesting today. So some of the design principles that we'll be diving into are, it's simple, pluggable, reliable, extensible, and scalable. Now, as we dive into each of these, I would like you to pay close attention to them because I hope they will inspire you to apply them not only in software that you're building, but also to some products that you're building, not just to a library, but also to real world products. So a little bit about me before we begin. That I have known nilenso from 8 years back, and when we were working together at Gojek and learned from a lot of folks working there. So 2 years back when I was looking for a switch, nilenso had me at nice and passion people. So the thing that Steve kept mentioning, like the thing about Clojure community or us is trying to be nice. So I love Clojure, Golang, and Ruby on Rails. I have worked on all of these languages in production for 2 to 3 years, and they are all dramatically different from each other. Some of you are, I can see some of you are smiling. But something which is common in them is that at the core, they are all same. Simple, non-breaking changes, flexible, powerful, etc. And I play during fun pickleball and football. For those of you who don't know about pickleball, it is a very moderate exercise sport which is not as popular as it should be in India. Like it is a mixture of lawn tennis, badminton, and table tennis. So it's fun exercise. If you want, do check it out. And another update is that my wife Kruti and I, we welcomed a very naughty and adventure-seeking little boy Ivan, just 4 months back. So, like Steve said in this talk, I hope Ivan uses this pic in his slide, that his first computer was MacBook M3, ducky keyboard, widescreen monitor. Yeah. I'd like to make a note that I have shared the slides on this link and even shared them on my social media handles. So no need to take notes. You can refer to these slides later if you'd like. And I'd like to say that I'm trying to keep this a fast-paced and fun-filled with engagement, discussion. So I'll request you all to not use your phones during this because it might be difficult to build context if you lose it midway. And there are certain terms which I'll be using repeatedly. So for those who are not very familiar with the concepts of background processing, I'll quickly define them. So what is a job? So any function that is executed in the line of flow of a program, but instead of executing it in line, you rather enqueue it for asynchronous or scheduled execution. That is called a job. Now, the entity enqueuing a job is called a client. The entity which stores a job for execution at a later time is called a broker, and the thing which pulls from the broker and executes the job, they are called workers. Without further ado, let's start. First, we'll be talking about simplicity. So API or UI, application programming interface, is the first impression of any product. Okay? And as you would have experienced yourself, application is directly correlated, like adoption is directly correlated to simplicity of use. Now, unless there are no other options like the IT returns website or Amazon 15 years ago, how simple your API is will have a huge effect on the adoption. So let's take an example of a function which sends email. Now, if you want to call this function, you will give it a subject and you will give it a couple of recipients, let's say foo@gmail and bar@gmail.com. Now consider that you want to, instead of executing this function synchronously, you want to enqueue it as a job. So this is how you can do it. You call the Goose perform async method and you give it some opts for configuration and you give it the send email, not just the name of the function, but a fully qualified namespace symbol, and then you give it the args just like it. So pay close attention to how the syntax is similar to a direct call, but just right amount of difference that. So developers have to only prepend 2 words syntax wise and least amount of friction. So we spent a lot of time coming to this simple API design, and let's look under the hood what all we did to come to that. So the first thing we need to do is we need to serialize a function so that it can be stored in a broker. And one way to do that in Clojure is you can take any name and change it to a fully qualified namespace symbol. So send email backtick gets converted to inclosure.myapp, which is the namespace, and followed by the name. So this is one part. We'll see how this kind of serialization helps later. Then we serialize the args. Now, one interesting thing was, what if some argument is not serializable, right? It can be an object or some in-memory data. So the way to do that was we encoded, like how do we do validation on serialization? Encode something, then decode it and again encode it and see if both those encodings are the same. So that essentially means that those args were serializable. So client then enqueues the job to broker, worker dequeues a job, and it first requires and resolves this function symbol and then just executes it by applying the args. So the first design principle that I would like you to take away from this talk is that simplicity is complicated. Now what this means essentially is, first of all, for those of you who don't know, Rob Pike is like the messiah of Golang, and this is a very famous popular talk of his, Simplicity is Complicated. If you have not watched it, I'll urge you to watch it. In this talk, what he said is that if something is simple, there is a very complicated, complex thing in the background which is powering this thing. And we did a similar thing in Goose as well. That is, as you look at this, this require resolve function. So what it does is it takes this inclosure.myapp send email, it converts it to string, splits using the forward slash, takes the first part, converts it to a symbol, requires it, so that's requiring the entire namespace, loading it, and then resolves that to a function, and then the worker can execute this thing. So there was another way we could have done this thing, which is a simple config mapping. We could have asked users to have a send email or string or keyword map to this send email function. Now that would have increased friction, and users would have to remember to, whenever they're adding a new job for async execution, they have to update this mapping. When they're removing a job, they need to remove that mapping. So we made this trade-off purely for the user's simplicity, And as a result of that trade-off, we have such a good API design. Second thing we want to discuss is pluggability. Now, this is a general question. What comes to mind when you want to store jobs? In your organizations, you might be doing background processing. One is Redis, that is RabbitMQ, Kafka. These three are quite straightforward. Most of the orgs use them, right? Which is the best? It all depends on the use case. Now, it would surprise you to know that some orgs are also using Postgres. And there are popular libraries like Golang's River and Clojure's Proletarian who use Postgres as a broker for storing jobs. And Mongo, this is the most surprising, but I can testify I was at Rippling. Rippling uses Mongo as a store for jobs. So before why I asked this question, we'll answer after this slide. Same thing goes for metrics protocol. StatsD, Prometheus, CodeHill metrics, anything people are using that. So as a library, it does not make sense to restrict users to just one thing, right? So for those reasons, in Goose, we chose to have pluggable brokers and metrics. Now what this means is that you can choose to use whatever you want. You just have to build an implementation of it and plug it into Goose. So for a broker, let's say right now Goose supports Redis and RabbitMQ natively, but you want to build some on top of AWS SQS. So you adhere to this interface, plug in your broker in Goose, and voila. You don't need to incorporate, let's say, Redis or RabbitMQ if your org infra does not have it already. Same thing goes for metrics as well. So Goose has out-of-the-box support for StatsD, but if you are using, let's say, Prometheus or some other backend, then you can implement this interface and plug that metric into Goose. So that's all. So the second principle around pluggability, what I'll say is that have configurability, like keep everything open, but with sane defaults, right? So a real-world example of simplicity is, let's say, UPI. You can do it very simple, it's fast, it's interoperable. Now, for pluggability, a real-world use case would be ONDC. So for folks who don't know, it's Open Network for Digital Commerce. What it has done is it has unbundled and e-commerce and made it interoperable. So using an Uber app, you can book an Ola driver. Using a Flipkart app, you can book, buy a parcel from an Amazon seller, stuff like that. So if you don't know about ONDC, I'll urge you to check it out. It's really cool. It has just transformed an e-commerce into Lego blocks that you can build using open protocols. Next, let's talk about reliability. Now, we believe it's 2024. Reliability should be built in and first class and not a paid add-on. And think about this, like getting to 5 nines. That's what all people talk about. This seems like a very hard problem, and it is hard, of course, but getting there is very simple. You just have to ask yourself one question. Every step of the way, ask yourself one question: what if this fails? And when you do that while writing code, right? That what if this fails, you have some error handling and some exception catching. But apply that to all the concepts, and you will have a very reliable product. So the first question, like a client sends garbage data to the broker. What can Goose do? So you can have specs and validations to prevent those garbage data from reaching the broker. So the args serializable spec that I showed earlier was an example of that. What if a job fails with transient error, right? Something which is transient for now but will recover later. So to solve that, you can have retries with exponential backoffs, right? What if now the job retries are exhausted? The transient error was not transient, but it was actually a bug, and your 10, 20 retries, they got exhausted. So instead of discarding that job altogether, you can store them in a dead letter queue. And you push your bug fix and rerun those jobs. Broker storage exhausted. many a times it can happen that due to a sudden burst of traffic, your broker's storage, it gets exhausted, right? So you should properly plan for your worker infra so that the broker store does not go out of hand, and have auto scaling in place for the worker infra that goes up and down as required. Now, this is an interesting bit. Like, you do everything well, but this is not in your hand. Sometimes with cloud providers, a VM can disappear off the shelf, right? So what if your worker dies unexpectedly? You put in a graceful shutdown and all that. So what can you do in that case? So instead of pulling a job from a broker, what a worker will do is, it will keep it in the broker until it has completed execution. So those jobs are called orphan jobs if the worker dies while executing them. And then the worker by itself retries those orphan jobs. How you can do that in RabbitMQ is using acknowledgements. You pull a job, you finish its execution, and then you acknowledge RabbitMQ, then it will clear it. The way to do that in Redis is you dequeue a job from a queue and preserve it in another queue, which is called the orphan jobs queue. And what essentially means is, if the worker dies, another worker will pick these orphan jobs after some time and execute them. Another question, what if this fails? What if your broker node crashes? High availability infra. So to do that with Redis, you have Sentinel, and in case of RabbitMQ, there is a cluster, right? So what I would like you folks to take away from this is, like, keep fault tolerance and redundancy in mind, and that will give you a very resilient software. And if you want to learn about this, I would suggest reading certain books about aerospace systems. They have backups of backups of backups, right? Not talking about the company where one door closing opens another door, but other companies, they do resiliency well. And our attitude towards reliability as a software developer is going to make all the difference, because any piece of product is only as reliable as its underlying infrastructure. So, for example, when you're designing for pacemakers, it has to be very reliable, but it need not be the same case for something like a Bluetooth remote, for example. But it is paramount that we design software in a reliable manner, because as we are growing, or even as we speak right now, everything's underlying layer is becoming software. Finally, now let's talk about extensibility. So we spoke about simplicity, pluggability, and reliability. Now extensibility. We all like Power Rangers, right? And have you, like, many a times customers, product managers, they come to us like, I want this feature also, I want that feature also. But it's not possible to build every feature into your thing, right? So how do you do that? Like, the core needs to be the same. Without modifying the core, you can have infinite features and applications of your product. So one way to do that is middlewares. In my experience, I've seen that middlewares, they significantly enhance any product's versatility and all the potential applications of it. So I've had users come to me asking for building a batching feature. Right now, batching feature is built, but 6 months back it wasn't. So I showed them that using middlewares, they can build batching feature, and they essentially did that. Within like just 2 days of work, using middlewares, they were able to build batching feature in Goose without Goose supporting it, right? Another complex thing is Airflow DAGs. So Airflow has complex, graphs and all that. So if this job fails, you do this. If this job returns value X, you do this, and stuff like that. So you can build all these complex pipelines using middlewares. So post and execution, looking at the result, you trigger something and stuff like that. So, and you can also have middleware ignore known errors instead of bubbling them up for retrying and going in an infinite loop. So, open to extension and closed for modification. Any software that you're building, try to build like this. A real world example of this I can give you are CRMs. So Zoho, Freshworks, and all that. They build the core CRM, but they realize that users have infinite requests. you might yourselves would have reached out to them with, hey, can I have this? They can't build all the features, right? So what they built was, they built an extensible system. You build your own pluggable thing and just plug it in. Same stuff for integrations in app like Slack and Jira. Yeah. And finally, let's talk about scalability. So scalability is not just about how can I do 10 million requests per minute, how can I handle petabytes of data coming in, but it also arises from how you are designing something. Bare minimum I can talk about is dependency injection versus global singleton. So you might know that since past multiple years, this debate is going on, and it is kind of settled that dependency injection is more testable, it is flexible. But however, despite this being common knowledge, or so we hope, most of the libraries, they force you to init one broker, initialize a broker at startup, and stick with that. So now this is what we avoided in Goose. We decided to let users inject the brokers at runtime or at execution time. Reason for that was complex production systems, they require multiple brokers. You cannot restrict them to just one this thing. I'd rather a user handle multiple brokers within their code than create a new microservice because the library was forcing them to just use one broker, right? So this is one instance where Goose decided to use dependency injection or global singleton. And again, I am of the opinion that in most of the cases, DI is much better than singletons. Now, you might argue that had we used global singleton, the API would have been a bit more concise. Like this ops would have disappeared, right? The config that's going in. But we felt that this small trade-off was okay to make. And another thing is, users have to pass these dependencies everywhere Goose is being used. Now, this is where optionality comes into place, right? That here, users can choose to define the opts, the config, as a singleton themselves and refer it always. If the library enforces it, then it's not possible. But if the library asks for dependency to be injected, users have the option to just define it as a singleton and call it. So that's why I feel like optionality over enforcement is better. Another thing which helps with scalability is something like batching. So batching is there might be a collection of jobs that you want to execute together and also track together, like when they are completed, right? So why batching? Like it reduces the client broker chatter. Instead of enqueuing 5,000 jobs 5,000 times talking to the broker, you just talk once and enqueue those 5,000 jobs. You can collectively track them. And again, like middlewares, you can build complex workflows after a batch completes what to do and what not. So finally about this thing, scalability, I would say that optional design is timeless. Okay. Now, best example of achieving scalability is NEFT. You folks might be transferring money to your friends' bank accounts, right? Ever wondered how NEFT works and why it takes 2 hours? So I'll try to explain it as simple as possible. So NEFT works in batches of 30 minutes. So let's say you want to transfer money from your bank to your friend's bank account. In the first batch, what NEFT does is, it will transfer the money from the bank to RBI. Second batch, RBI transfers to the bank. In the third batch, your friend's bank reconciles with RBI that yes, I have transferred the money in the recipient's account. In the fourth batch, RBI reconciles with your bank that the money has reached your friend's bank account. So these 30 minutes of 4 batches is why it takes 2 hours to complete an NEFT transaction. And I don't know the exact number, but it will definitely be in billions of NEFT transaction happening in a day. So we are able to achieve that using batching, designing for scalability. We are about to close the talk, so I'd like to quickly go over certain things which are community standards that we have done in Goose. And this is common knowledge, but I don't see everyone enforcing them. So something like README. So README should be as simple as this. Like, it should not be intimidating, and it should have the minimal amount of code that a user needs to get started and do a POC for themselves. So that's what I feel about how a README should be. It is paramount to have a comprehensive wiki. You can't just say that, hey, I have batching, I have periodic jobs, I have priority queues. You need to explain to your users how to use them, right? Auto discovery of features seldom works. Now, it is important to document your ADRs. Like, in the past 2 years since we've been writing Goose, there are so many small things that come into our mind, and we make certain trade-offs, right? So had we not documented all of that in ADRs, someone else later might come in and ask the question, and we will not know the answer to that. But now, for any user or potential contributor of Goose, these ADRs are the go-to place, the first thing that they read and understand that, oh, this is done like that. So simple example of that is scheduled jobs. So when a scheduled job is due for execution, it needs to be moved from the schedule to the ready queue. Now, a queue has two ends, front and back. Where do we put the job, right? So both answers are correct, but we chose to put a scheduled job in the front of the queue. Why? Because we wanted to care about the SLA of a job. If a job is supposed to run at 255, then putting it at the front of the queue reduces the SLA of chances of missing the SLA. If you put it at the back of the queue, there will be a large, there is a large backlog. Then the job scheduled to run at 255 might run at 3 o'clock, 4 o'clock, God knows, right? But then this might seem effective, but there is a small trade-off as well. Like, let's say that job scheduled to run at 256 was put at the front of the queue, and this previous job was not executed. So what that means is job scheduled for later will be executed before the jobs scheduled earlier. So we made the trade-off. There's nothing right and wrong between both. We made the trade-off and we documented it. That's the right thing to do, documenting it. Another thing about doc strings. So Clojure has this beautiful things of doc strings, and you should have them at least for all the user-facing functions. If I had to give an example of a doc string, I'll say that, look at this lanyard. It has vital information, and it is within arm's reach for you. So in front is your name, and if ever you want to look at your schedule of the conference, you can just flip it over and look at it. So a doc string, or how to use a function, is just like this vital information, and we should keep it at arm's length. So when a user is doing GoTo definition, they can look at the doc string and do that. Another thing good thing about Clojure is the CLJ doc. So it takes when you publish a library or thing to Clojures, it generates documentation in the formatting, and it hosts it in its website. So if you were to document, put your doc strings in a format, they'll show up beautifully like this. Then I cannot stress this enough, you should be present on all the developer forums, be it Clojurian, Slack, Reddit, Twitter, so users can have a direct connect with you. The reason why I said I cannot stress this enough is features like pluggable brokers, pluggable metrics, batching requirements, all of these inputs have come from customers like AppsFlyer, Bcastle, and all that, who are using it in production via these forums. They did not come via GitHub issues, they came via this forum. Now, another thing is that a lot of times, not just libraries, but products also have ambiguous terms. So I'll say that use non-ambiguous terms and use one term as much as possible. For example, we use client instead of just application or publisher of jobs, broker versus backend or store, worker versus a subscriber, observer, etc. We use periodic jobs instead of cron jobs. Like cron is an implementation of periodic job. Periodic means that it runs at a recurring time. So we decided to use periodic jobs. Throttling. So who here knows the difference between throttling and rate limiting? So throttling is basically you limit it, and if 100 jobs are running at right now and you want to throttle it to 50, the other 50 jobs you pause them to run at a later time. At rate limiting is if 100 requests are coming in and you only want 50, the other 50 limits get discarded, APIs get discarded. So that's the meaning of rate limiting. So for those reasons, we use the term throttling instead of rate limiting in Goose. And same thing goes for console. So we are about to build, in the process of building a UI for Goose, and a lot of other libraries, they are using the term dashboard. Now dashboard is for mostly consumption of information. But when you want to make changes and all that, it's called console. You might have seen in Google Cloud, AWS, they call it console.gcp. So there's a sneak peek in the Goose console that will be released in a few months. And yeah, that's all. Thanks. Okay, where's Nina? Yeah.
There might be questions.
Yeah. Hi, Nate.
You talked about reliability when talking about Goose. Does it add to the reliability of the brokers, the underlying brokers? Like, say, if I have, you talked about like clustering of RabbitMQ or Redis, Sentinel. Does Goose as a library add any kind of reliability or guarantee on top of what the brokers already give you?
So Goose uses the constructs of a broker to give enhanced reliability. So for instance, in Redis, you can pull out a job and work on it, but Goose chooses to dequeue and preserve the job in Redis. Same thing goes for RabbitMQ. You can pull out a job with and acknowledge it, but something like high availability of the RabbitMQ, you will have to do it yourselves.
So basically, I was wondering mostly around the extensibility of it. If I want to write my own broker, the onus is on me to ensure that there are no guardrails in Goose as such to ensure that.
No.
Okay.
So guardrails in Goose are limited to the level of retries. So
Right.
retries can happen by themselves, but this thing like keeping it in broker will have to be built by the implementer of the.
Got it.
So when you are saying about that putting it on the front of the queue rather than putting it back, so that's a trade-off that you have made. But how do you think about exposing some of these trade-offs to users as a flexibility option, rather than I'm sure that how do you plan these things while building a library such as this?
Yeah. So we want to keep things optional, but too much of optional and configurable will kind of cripple the user. So for those reasons, my understanding of your question is, why is putting at front versus back of the queue not configurable, right?
Yeah, when do you decide that a flexibility, trade-off should not be exposed as a flexibility
Yes.
to the end user?
Yeah. So this is, I would say, we make the decision at the high level. For instance, when it comes to broker selection, metrics backend selection, we make that configurable. But when it comes to something like a nitty-gritty detail, like where a scheduled job goes, we communicate to the user that this is how it's implemented, and we again then, for instance, let them know that there's a disclaimer that this can happen. A job scheduled to run at 3 o'clock might run before 2:55, and there are a lot of other things as well. For example, item potency. So a job could run more than once, right? Even if it was successful, because the worker could not fail to communicate to the broker that this job is executed. So certain things we put them as a disclaimer and nuances to the user, and certain things like these broad things which are big, like broker and metric backend, that we keep pluggable. Does that answer it?
Yeah, what I was trying to say was that some special cases, not missing that timeline is important to the end user, right?
Yes.
And since you are not exposing it on the options level for a library, then the obvious solution would be to, I guess, put it in a global setting sort of thing.
Yeah.
And if we opt to not put it at either end of the place, then the end user might not even have such an option, as in the library will will not be able to provide a very essential feature
Makes-
for some segments.
Makes sense. This you are the first user to bring this up. This could be a potential thing which can become configurable, whether to put it on front or back of the queue.
Yeah. So yeah, I was just wondering like
Yeah.
how you decide on these things and
Yeah.
yeah.
Thanks.
Thank you.
Is that something you can fix in middleware? No, this can't. So Nina's question was, could this be fixed using middlewares? Yes. So before execution, you can put in a middleware, which checks if the 3 o'clock job is running before 2:55, and instead of executing it, the middleware just re-enqueues it to the back of that other job. So, but also another thing, caveat that goes with all asynchronous libraries are, and because it is an underlying feature of the broker or the setup. If you have one worker listening from one queue, then everything will be in order. But there are n workers, and inside a broker also, instead of one queue, there will be n channels like in Kafka or something like that. So in order guarantee is not something which is possible when you are running more than one worker, because another worker might be stalled for whatever reason and the other worker will be faster. So stuff like that.
Yeah. So, so because Goose is making decisions on when to reschedule or retry some messages, it will have an impact of metrics, I suppose.
Yeah.
So when we look at the metrics of the underlying brokers, do we need to see that in conjunction with metrics of Goose, or does Goose add some metadata that we can just see the underlying broker metrics and see that things happened like retry and rescheduling?
So Goose metrics are largely from the worker's perspective. How many jobs were executed, percentage of them succeeded, percentage failed, time it took to execute. A broker metrics would be something like, for example, you set up a Redis or RabbitMQ. You'll have to set up a StatsD plugin over there which scrapes those metrics and pushes them. So those broker metrics, like I would call them system level metrics versus application and business metrics. So Goose focuses on the application metrics. You can derive business metrics from application metrics, and system metrics you will have to generate from the broker itself.
Okay.
Yeah. How do you make the workflows?
Sorry, where are
Yeah.
Yeah, hi.
How do you make the workflows? Like you have a job, this will get executed fast, then again another job and things like that, right?
So you can use that, you do that using middleware. You enqueue one job, and depending on the result of that, there are two other jobs you want to execute.
Okay.
So you plug in a middleware that looks at the result of the job. It was foo, it runs this thing. If it was bar, then it executes this other thing.
No, let's assume that one fails, then I don't want to execute the third one.
Again, middleware.
Middleware.
Middleware, it catches your exception. In the case of an exception, it chooses not to enqueue it.
How is it different from the temporal?
I'm sorry, I'm not aware of temporal.
Okay.
Yeah. Hi. How easy does Goose make it to, like, how is it in Goose to make it expose Prometheus metrics, which pulls metrics and doesn't push like StatsD?
So you can look at the StatsD implementation. All it does is it satisfies that interface, right? And in Java and Clojure, there is a Prometheus library. So you can satisfy this interface, plug in your object in Goose, and use that Prometheus library to send that data over there. So it's that simple, just one object that satisfies 4 methods.
Yeah, I have a couple of questions. So first one is around the sort of reliability part, where the same function gets called multiple times. Is there a way we can specify uniqueness criteria along with the options that we send to that particular call to ensure that, even though there are multiple ways that the multiple places the same signals can be sent, but needs to be processed only once?
Yeah.
One question. And second question is on the Redis broker side, are you, is the client running multiple commands from the client to the server? Or in this case, does it also have Lua interop or any other server-side functionality that Redis offers? Are you exposing that?
Yeah. So the first thing is, there are no unique jobs yet in Goose. So certain background processing libraries, they have a uniqueness feature that a job will only executed once, or even if it's enqueued from multiple places. Again, you can do that using middleware, but until Goose does not provide that. By checking pre-execution if this, sorry, if this was executed or not. Sorry, what was the second question?
The second question is, are you using any sort of interop on the Redis server side to ensure the performance being higher?
Goose is not using any this thing, but plain connection pooling, all the best practices when talking to any broker, like connection pooling, and for instance, when there are needed for atomicity, then use those transactions. When there are multiple connections, you can pipe multiple commands which fetch the same thing. Instead of sending them n times, you pipe them into one and send it at once. So Goose only uses that. So far, there has not been a need for Lua scripting or something like that.
Got it. Thank you.
All right. Thanks a lot, everyone.